Alright, so I have myself this time around an initial value problem, and my initial condition is given as y0 is equal to, the e. Alright? Question here is, you can see that this is kind of messy a little bit, right? So if I look at the approaches that we have covered so far, is this separable equation? No, I don't think so. Is this linear? Oh, no, I don't think so. Because y and x are everywhere. So now I'm going through the list of what I covered, and the last thing I have is the exact equations. So obviously so far, right? Exact equations. So let's see whether this is an exact equation or not. And the process that we have completed for that is you remember I call this m, I call this n, and I said that which is del f del x, this is del f del y, and now I have to establish whether del m del y is equal to del n del x. Okay, let's put it in. Del of y squared cosine x minus 3x squared y minus 2x. Hopefully this is not going to give me a trouble. It looks like a complicated case. And I'll do the same for the n. 2y sine x minus x cubed plus ln of y. Okay, let's not panic and do this one by one. Let's do our best. Okay. The first thing will be, let's take a look at the first term. So note that I'm taking with respect to y, be careful. So then this will be 2y cosine of x. Okay, so I got away easily in this one. What's next? The next term is going to be, if you take it, it's going to be minus 3x squared, and the last time doesn't have any x in it. Alright, good. Let's look at the second term. In here, with respect to x, I'm going to get, 2y is constant now. What is the derivative of sine of x? It's going to be cosine of x. What about the x cubed? So it's going to be 3x squared. So I will get myself this, and you're seeing something that I'm seeing, correct? They're equal to each other, right? So then this means there exists an exact differential that expresses this particular behavior. Okay, I will proceed with doing the approach that I have done. And I'll be honest with you, I don't know which one is easier to take the integral of, because in the previous segment I said that start with the one that you can take the integral of. The thing is, ln of y, I know it, y ln y minus y, but sometimes students don't know it, so I just want to let you know. I will still go ahead and stick to this and see what happens, okay? By the way, at home, you may want to start by this and get an answer. Go do the second step as this, and see whether you get the exact same answer as me. So that's kind of important. So f x comma y then will be the integral of m. I'm basically looking at here. I'm starting with this. xy dx. Okay? And then I will insert what I see from the m. And that will be y squared cosine of x minus 3x squared y minus 2x dx. So okay, let's proceed. When I take the integral of this with respect to x, I'm gonna get myself y squared sine x, right? How about the other term? It's gonna be minus x cubed y. So far so good. Minus x squared plus what? C? No, g of y. So now I know my f x of y, and I'll ask you the same question. Am I done in here? No, not really, because I started with a function that I don't know. Okay. And then at the end of the day, I get myself a function, but it's a function of another function. So I have to find that second function that I don't really know of, right? And in order to that, I'll do the same approach as I did in the previous segment. I'll just use this and see what happens, okay? The n was 2y sine x minus x cubed plus ln of y. I just wrote this from memorization, so let's double check. 2y sine x minus x cubed. Yep, this is good. This is n will be equal to del y of this y squared sine x minus x cubed y minus x squared plus g of y this. Okay, the left hand side is the same. Let's look at the right hand side. The derivative of the first term will be 2y sine x. Okay, I'm doing fairly well. Minus x cubed and then plus g prime of y. So these two cancel, you see that? And right there and then, I get myself g prime of y is equal to ln y. Now, I said that at the beginning of this session, I said that do not stop at this because you may not what the integral of ln y is. And then I came into the same issue. Interesting. So I have to really find this, okay? And I said that this is going to be y ln y minus y, right? Let's say that there's a bunch of things to memorize and you really didn't really memorize this. So what am I going to do? Is a question that I have for you. So actually, let me go at one step. D g of y dy is equal to ln y. So from here I can get myself g of y will be equal to integral of ln y dy. I'll show you a tactic. This is kind of important. Okay. So actually, interestingly, integration by parts doesn't have to be multiplication of two things that I cannot get the integral of. All right. So I can simply do this. It's kind of interesting. If I call u is equal to ln y, right? The advantage of doing that is now I don't have to take integral of this function anymore. Now I'm going to take the derivative of. Do I know the derivative of ln y? Well, if you don't know it, you're in trouble, correct? But most of us do. So this dy by y, right? And then what am I going to call as dv over here? I'm going to call this dy, right? That's the only thing left over there. So if I have here, this v will be equal to y. So then if I go ahead and evaluate this, you will see what happens. It's going to be uv, which is y ln y, minus integral of v du, which is dy by y. So these two cancel. And I got myself g of y is equal to y ln y minus y, right? So as I mentioned this to you, let's not forget the integration constant, by the way, plus or the constant of c, right? So now you know what the integral of ln y is. Okay, then let's reinsert the whole thing. So f of x comma y will be equal to y squared sine x minus x cubed y minus x squared plus y ln y minus y plus a constant of c. So now I will do the exact same thing that I did before, and I will combine these two things, right? So this is a constant. This is supposed to be a constant because this is the variable. So I will get myself y squared sine x minus x cubed y minus x squared plus y ln y minus y is equal to k. That will be my function. Okay, this is the solution of that particular differential equation. Before I let you go, let's say that there's a student who didn't really quite capture the whole thing. And let's say that this was not an exact equation, but the student using the exact equation. They forget to check this. They are saying, okay, this looks like a differential form that you give to me, I'm going to go ahead with it. And let's say that this is not an exact. Where will you understand that you have an issue? When I grade your paper, that's option A. Option B, you can find it yourself. And I'll tell you where you will find the issue. If this was not an exact equation, you're going to understand this at this step. What will happen is it says y in here, and on the right hand side you will get a plus of x, something with an x. And you can see that that doesn't make sense. I'm saying that, hey, this whole thing is only a function of y, but you have an x, right? And then at that moment you have two paths. The first path is maybe you made a mistake, mathematical mistake. Double check your approach. Double check that everything was okay. If not, then you may want to go back and say, did I really miss any step over here? I forgot to check this. And if you check this, you will see it's not going to be exact. All right? That's just a hint for you so that you kind of get better grades. All right? All right. Did you forget anything? I did this on purpose, by the way. I had this conversation about how would you understand that you're making a mistake on purpose to see your attention. Is this it? Did I box it up and is this done? The answer is no. Why? This is an initial valid problem. You find me the general solution. This is called the general solution. I'm not asking you to find the general solution. I'm asking you to find a particular solution. In order for us to do that, I will have to go to this, for when x is equal to 0, y is equal to e. So I'm giving an initial condition for me. So let's find it. Y squared e squared sine of x is 0. Sine of 0 is 0, right? Minus x is there, so 0 minus 0 plus e ln e minus e will be equal to k. So what is ln e? 1. E minus e is 0. So I got myself k is equal to 0. So then at the end of the day, this particular solution that I was interested in turns out to be this. Now I can go and celebrate. I'm done this time because this is called a particular solution, and this is as far as I can proceed. Okay, have a good day. I'll catch up with you in the next segment.